In this video, I'm going to demonstrate how we can express transformations as a completely different function. Let me explain what I mean by that. So let's say, for example, I go from f of x and I basically translate it to g of x is equal to f of x plus 3. All right. So normally what we've been doing so far is I've just been writing y equals f of x, and we've been, and I would just show you f of x, and I would just say it's translated to f of x plus 3, and then I would write the transformations. This is the first time where I've introduced a completely different function called g of x. But this is actually not that difficult to comprehend. All I'm saying right here is that here my first initial function is f of x, and I'm translating it to f of x plus 3, and I'm calling that function g of x. So in other words, I'm going from f of x to g of x, right? And what I'm doing is I'm obviously translating it to the left by 3, but after I translate it to the left, that transformed function is called g of x, and that's basically it. So say, for example, if I were to write something like this and I ask you, what is the translation, state the transformations from f of x to g of x, all you would have to say is simply translate, and if you observe, this is 3 to the left, so you would say -3, 0, right? There's no stretches, no reflections, and no vertical translations, just a horizontal translation to the left by 3. So if I'm going from f of x to g of x, all I'm doing is translating -3 to the, or 3 to the left, and there's no vertical translation. All I want to get across with this video is that all I'm just trying to say is that after I make a transformation, I can call that transform function anything else. So in this case, I call it g. So I'm going from f to g, and how am I doing it? I'm moving 3 to the left. Let me show you another example. So let's say, for example, I'm going from, so this is example 2. So I'm going from f of x to h of x, right? And I tell you that h of x is equal to 2f of x plus 1 minus 3. So the question then becomes, what are the transformations in order for me to go from f of x to h of x? Well, we know that h of x is equal to some function of f of x. And what have we done in order to go from f to h? Well, let's look at if there's any reflections. There's no negative here, no negative there. It's already factored, so there's no reflections whatsoever. There's a vertical stretch, or a stretch in the y direction by a factor of 2. We move to the left by 1 and down by 3. So let's just write all that down. So all we're going to say is a stretch in the y direction. Now, normally I should write by a factor of, but I'm just simply going to write 2. So by 2. So a stretch in the y direction by 2. And simply, it's just translate. So it's -1, meaning it's 1 to the left, and then -3. And we're done. All right. So those are the transformations to go from f of x to h of x. And once again, since I have an equation that expresses h of x in terms of f of x, I know what the transformations are. I can just read it off. All right. So I hope that sort of explains things, and I'll see you in the next video.